So let's start from scratch, and that will leave time for people to join in. So welcome here to this new Munch and Learn event. My name is Frédéric Passeron, and today with me is Ted Dunning from HPE. He's a fellow in HPE, and we'll be talking about how to fix your biggest security hole. And I have no clue which hole you're talking about, which security hole you're talking about, but we'll be very happy to figure it out very quickly. So hopefully people are joining in. And before we really start with the core of the session, as usual, as you probably know, we need to go through a few housekeeping items. So we're attending today a Munch and Learn event. And for those who are not aware of this existing program, well, let's say that the HPE developer community has several kind of assets, among which you will find the Munch and Learn that are monthly series. And they are kind of thought leadership type of discussions, and they're vendor and product agnostic. Okay, please go on mute. And obviously, this is a long series, and if you're not aware of the previous session that took place, my colleague Denis will obviously paste in the chat some of the links that are relevant to this mentioned learn, and you'll be able to find out the forthcoming session as well as the existing sessions and the replays that have been done for these different sessions. There are no Munch and Learn planned for December yet, but overall there will be some other events that will be taking place in the months of December, among which you will find some meetups, and where the Munch and Learn are high-level type of discussion, the meetups seems to go down to the bone. They're really in-depth type of talks on a given technology. It usually relates to developer, open source, and many more other subjects. On December the 18th, we'll have the pleasure to welcome Antonio, Finn, and Kong Chu from HPE, who will be talking about large language mesh, democratizing Gen AI for everybody. So, and this will take place on December the 18th. Again, I'm pretty sure that Tony is pasting the link in the chat. In Zoom, the chat is not clickable, so you'll have to copy paste in another window to actually reach out to the link itself. We lately introduced a new series in our different talks. I think it started in this September. And these are called the Keeping It Real with AI Jam series. The purpose of the call of the session is obviously to talk about AI. And these series are actually a panel discussion on AI subjects. On December the 11th, we'll be talking about picking the right software for your AI use cases. So please do attend and register for these forthcoming sessions. On top of these events, obviously, the HPE developer community is providing different additional assets, among which there are the workshops on demand, and this is my little baby, and I'm very proud of it. So you can actually go there and figure out the catalog that is existing. The workshops are actually hands-on, experience-based, Jupyter Notebooks-based workshops, and they're available 24/7. They're free, and they're available for you and your customer. Please give it a try and provide some feedback. This is really important. And we released today a new Sustainability Insight Center API 101 workshop that is being used currently by Didier, who is in Discover in Barcelona, and is supporting the hands-on lab activities over there, and some expert session as well. And obviously, as you know, the developer community is a community, so we need you to amplify and contribute to the community in many ways, in different ways. So you can join our talks, obviously, as you are tuning today. You can also invite others to join these talks. I mean, you can ask them to subscribe to our newsletter, okay? They can also participate in different channels, workspace that we have in Slack. Okay, and there you can ask questions and get really good answers from people like Ted and many other people, experts in different kind of subjects. You can follow us on X and Twitter, obviously. And should you be a subject matter expert, well, you can work with the community and with the team to write a blog or to build up a workshop with me or to attend to an event and present on a given subject if you want. to summarize all this, we have this wonderful slide that you can add to your slide decks. And well, this will give you all the different links that are necessary to promote and advertise and evangelize the HP Developer Community Program. So without any further ado, I will leave it now to Ted to tell us about the security hole that we need to fix. So I will be stopping my sharing and you can take over, Ted, and the floor is all yours.
Okay. And I want to encourage everybody, if they have a question or whatever, go ahead and pop it into the chat, and Frederick will be watching that and will be able to interrupt and introduce your question into the flow as we go. I've also allotted a fair bit of time at the end so that we can have some nice back and forth at that point. So do keep an eye on things and do speak up if it seems confusing. And I just wanted to add a little bit. Normally you'd be able to find me on Twitter, but I've emigrated, and you can now find me on Blue Sky instead, tdunning.bluesky.social. Okay, so let's get started. What I want to talk about, as the title somewhat controversially says, let's fix the biggest security hole you have. And the idea here is that the biggest problem is actually, and this is not actually controversial, it's your users and the fact that your systems are difficult to use. Most people would start by giving you a list of features like this that make things difficult, but frankly, you just tune out. What really matters in a lot of ways is that bad things keep happening. A year ago, for instance, but this happens every month practically, somebody makes a horrendous mistake, like giving up the root account credentials for all of your machine learning research group and all of your machine backups and all of your private messages, because this researcher was told to share a small data set. And they shared the data set. They unfortunately shared everything else as well. And this is the kind of mistake that happens. Somebody at a bank misconfigures the training data. Somebody at an insurance company, they misconfigure the permissions on their internal archive files. All of these sorts of things happen. And it's because things are just too complicated. Users cannot get this right if they're doing their job. Now, a secondary problem, which is largely to compensate for the first problem, is that we have super users who can do anything. Well, that's a bug. That's not a feature, because those super users have enormous powers. And so when they screw up, they can massively screw up. And if they become an insider threat, they can access anything. Edward Snowden, for example. And then there's a more subtle problem. And I think you've probably seen that if you work in a large group, where the producers of the data produce the data for their own purpose, and they get the value from that data. Somebody else may now want to use that data to share that. But typically in a big company, the way that that has to happen is that the producer has to publish that data in some way. They have to curate what data is available. They have to provide an API. They have to do some work in order to share with the new consumer. That means the pain is on the producer and the gain is on the consumer. And whenever you displace pain and gain, then you have a problem, because nothing ever happens. And then another subtle problem, not just the pain and gain thing, is that we want to be able to have large-scale overall controls that set corporate policy, like don't screw up massively, don't share anything under this whole area. But then we want to be able to have small-scale, detailed constraints about, production and development have this relationship and so on. But we want to be able to inherit the large scale at the small scale. And we'll want to be able to manipulate and control the small scale without interference or required cooperation from the administrators who handle the large scale. So we have this independence that we need. Now, who wants this? Well, basically everybody. We need to make it simple so that people can understand it. We need to separate the concerns to avoid interactions. We need to provide that no super user so that if you have the corporate administrative control, you can't see the low-level data. And we need to be able to have this auditable and even verifiable with formal proofs. And we need to be able to check these policies on every metadata change. And it should apply across all of the storage modalities that you have, from the largest to the smallest, from the slowest, say S3, to the fastest, say Deos on a high-performance computing system. You want all of these things to have a unified scheme for access control. So we need it ourselves at HPE. We have car makers who are very, very interested in using it. We have HPC customers who need it, who want very fast, very clean permission, and they want to share those machines more and more. And we have unnamed government customers who have urgent needs. Now, let's talk about our approach here. The idea here is that we're going to create a global namespace. All data elements will be included in this. Furthermore, all user identities and workload identities and the attributes used to express the security will be in that same namespace. Everything will have a global name. It's like a URL, but it's a security URL. It's an entirely virtual namespace. And then that namespace will be nested with directories and subdirectories and users and data and so on. And so we'll be able to define inheritance. The user/Acme directory will have controls, and everything below that will inherit those controls. We're also going to go to access control expressions. This is both an extension and a limitation at the same time. It's an extension beyond conventional access control because it allows an interesting logical combination of controls. You can have access control expressions and you can end them together. You say, this person has to be an HPE user and they have to be in the development group. And the development group is an access control list of attributes and that sort of thing. And this anding allows us to separate the controls so that one part of that is the corporate control and the other part is the local control. And we can nest that even further. But we don't want to make it too complex. We don't want to go to a full Boolean expression because a Boolean expression would include ORs at a top level, which would mean we would be able to relax the constraints at a low level that were imposed at a high level, which would get rid of the major point of inheritance. And so this is an interesting tightrope there. We also want these controls to be what is called capability-based. You're presented with a credential that lets you do what you want to do, that you could even delegate a bit to some software working on your behalf. You would log in and get your credential, and you would delegate access to certain kinds of data to a dashboarding application. And this is an important thing because it gets rid of what's called the unreliable deputy problem. We'll talk more about that. Recently, we've also added the ability to have this same uniform control apply at the cell level, at the field level inside a database. That's also, frankly, at a row level, a column level, as well as the individual cell level. Now, that obviously can involve checking security constraints a billion times, maybe in a second even, or in a few seconds. And so this bearer credential is very important there so that the database itself can be co-opted into doing that checking very, very efficiently. You don't need a round trip to some figure of authority in that critical hot path. We also then maintain all old versions of the metadata so that you can look at the history. So back to this. Everything has a path, the data, the users, the workloads, the roles, aka attributes. Also, enterprises have a directory. Departments within an enterprise have a directory. Projects within a department have a directory. Then they can apply those controls at that level. We're going to allow any kind of identity that the corporate identity control people approve. So we're going to have multiple forms. This idea that the universe is divided into authentication and authorization is not really true. There's many kinds of authentication in play at once. At the very least, we authenticate applications differently than people. But then we generally have some sort of long-term migration from the old system to the new system. And so we've got multiple forms even just within the users. So you bring your own and you approve whichever proofs of identity you want to allow. Everything has access control in addition. So users and attributes and data and workloads all have access control, different kinds. For data, you want control over, can you see it? Can you read it? For users, you want control over who administers them. On attributes, you want control over who can put those attributes on users and use them in access control expressions. All of these rights can be delegated. Yeah, Frederick.
If I may interrupt you just a sec. We have a
Yeah.
question from Derek Schumacher. He's asking and he's stating some government partners have expressed interest in ABAC, attribute-based access control for fabric-attached resources that may be shared amongst a number of agencies and departments. How, if at all, do you see ABAC fitting in your approach here?
That's a great thing. I always try to avoid jargon, but then when somebody puts a requirement down that's in terms of jargon, ABAC, which means attribute-based access control, I forget to tie it back. This is, in fact, an attribute-based access control system. All of the constraints on access and administration and things like that are expressed in terms of attributes, not in terms of identities. That's what makes an access-based or attribute-based access control system. And so, yes, that is very, very important. The reason that that's important is because you want the access to be granted based on the job somebody is doing right now, not based on who they are. That means that when they go on to do another job and you move them into a different directory, move their identity, they lose all of the previous access and gain all of the new access. That's a very, very important characteristic. And you want to be able to have somebody take on that role that they were playing, take on the job they were doing very easily. And so you want them just to go put them in a directory and inherit all the attributes, and therefore they will be able to do their job. So ABAC, access-based access control, is a very important property of what we're talking about today. That's a great question, a great catch, and I appreciate that sort of thing. So keep them coming. So let's talk at the beginning here about inheritance, delegation, and isolation. So we just heard a question about sensitive government applications. These people are very, very touchy about exposing data. They really don't want to do it. But that same sort of constraint applies in commercial settings as well. And that's what I've drawn here. It's very common that you'll have multiple companies having data in a similar system. And they may want to share that data, but they still want to maintain their own scope of control. They may have different systems of approved identity proof. They may have data in different storage systems. They may have data they want to keep completely private and data they want to share with partners. And so what we want to be able to do is have policies set at, say, the Acme level and at the Yo-Yo-Dine level that are independent. And then we want those inherited to the units within those enterprises so that sales may set further constraints, but inherit the Acme corporate constraints. The same thing is true in engineering. And then we want to be able to have identities within those departments. Like Alice in engineering is an administrator. That's why I drew her identity with a double circle. And Alice in sales is an administrator, but these are two different people. There's another Alice over at Yo-Yo-Dine. Again, a third person, even though both Alice's here and there work in sales. We want to be able to have this idea of directories and delegation so that Acme top level can set some policies, be the only one who can administer those policies here, but then have new policies be introduced at the engineering level or even below that at the product level. And we want to be able to give up control to a lower level, but not give up the confidence that our constraints at the high level are going to be honored. So here's the way this works. In the beginning, the system is empty except for one user with one attribute. The user is the operator, and the attribute they have is operator. They have control over the four top level directories, data, roles. Now, role is just a short word. Here it means attribute. Attribute would have been long. So data, role, users, and workloads. They have complete control over all of these. And the control is set up so that it only applies and is not inherited. Here are the controls. In fact, the administrative control on each of these is set to the operator admin, and the right is the same. And the operator is the only one with the operator attribute. The operator attribute, on the other hand, can only be administered, applied, or used by the operator. So nobody else can use it. We then will extend this. I mean, obviously, the empty system is totally secure, but it's not interesting. So it becomes interesting when we have others involved. And here we have two companies, Acme and Yo-Yo-Dine. I've highlighted Acme. So Acme has two roles, administrator and user. So role Acme admin. And Acme also has one user right now, and Yo-Yo-Dine has one user. And we still have the operator. But we're going to put permissions. We still have the permissions on the top level directories. We put permissions on the Acme directories that say only an Acme administrator can administer those, only an Acme admin can write to those, and only an Acme user can even see them. Now, this is really important because notice the operator does not appear in this visibility here. That means the operator cannot see Acme. The operator has delegated all control to Acme's administrators. The operator retains control of the top level directories, but has delegated control over Acme. And that's an important thing to be able to do. The Acme admins now have complete control, just like when you have an operator-tenant relationship. At AWS, they provision things and give them to you, and you have the right to administer them any way you like, including screw up. If you want to delete your data or expose it or whatever, it's all your responsibility. At Greenlight, the operator, HPE, delegates control to the tenant. But then we want to be able to do that at a second level. And none of these existing systems do that very well, where we want the operator to delegate to the tenant, but we then want the tenant to be able to delegate to subtenants. And you can see how this works here. Acme could have other directories at a lower level that have sub controls. The visibility of these things within a graphical interface is very easy to explain. You can show users the attributes that they have directly. For instance, BU number one's admin control that's going to expire in a few minutes, and which things they inherit. I'm going to flip over to a small demo system and show some examples of this. Now, this isn't the full-scale access manager. This is a demo. But what we can do, for instance, we can look at the entire system. Here I put in Acme and FooBar. FooBar is a merger of Foo and Bar. These used to be independent companies, and now they're merged. Acme has one user, Fred, in honor of our host here today. And Foo has Alice and Bob, and Bar has Carmen and Dave. So there are ancestral users from before the merger, and there are users after that. If we look at what the operator can see, however, we're going to do the same LS, but this time as the operator. And you can see this is a demo. In a real system, you can't just say, oh, I'm going to do this as some user with no proof. But in a demo, that's useful. So we're going to look at the universe according to the operator. Well, this is all the operator can see. Whereas there were all those other directories inside data, role, user, and workload, the operator only sees the top level. And that's because the visibility of these different corporate environments is restricted. Let's look at how Alice, the administrator for Foo, can see the universe. She sees Foo and FooBar's data and users, and Bar, because it's merged now. So we've given all of the Foo users a Bar credential and a FooBar attribute, and we've given all the Bar ones also those same attributes. And if we look at it from the point of view at Fred, who works at Acme, you can see that Fred only sees Acme data because this permissions are set up correctly. In fact, we can look at the permissions. Here at the top level, we have the operator's permissions, and those are local, so they are not inherited. At the data level, we have the same thing for the top level, again, local. But then at the Acme level, we have a view permission. Only people with the attribute user can see the Acme directory. Well, here's where that attribute appears at the Acme directory, and it's inherited below this. And so Fred inherits Acme user attribute. So Fred can see all these things, and he can administer them as needed. And so you can see that all of these inherited controls are the dominant thing, and the inherited attributes are quite common. It really becomes quite simple when we see it that way. The operator retains top level, but delegates. The tenants can set control over their own areas. The tenant could also set something more nuanced. They could say, I'm going to keep the top level control. I'll let you administer within that, but I'm not going to let you change the visibility of that. So I could see the top level, and other people could see that the top level exists, or something like that. Or you can let it become invisible. The tenants can delegate in the same way. This is a huge factor. It's easy to do, and it's safe because of inheritance. And we begin to see how we can audit and prove this. What I like to go for what I call the 30-second audit. Is our data safe? Yes, because only people with the Acme user attribute can see anything to do with Acme. Oh, well, who has that attribute? We did a search, and the only place that that attribute is on the Acme user directory. Okay, who can modify it? Well, we check the permissions on that, and only Acme admins can do that. And here is the only place that's mentioned. Well, the audit is then done for that policy because we don't need to know the details. Nobody below those areas can cause data to be more visible than that top level constraint allows. The 30-second audit is complete.
Ted, we have
yeah, good.
I would like to interrupt you once again, and we have another question that is coming from Joe relating to RBAC. So a lot of what you're describing is also referred as role-based access control, RBAC. Are there important distinctions between RBAC and ABAC?
Yeah, so the typical difference between RBAC, role-based access control, and ABAC, attribute-based access control, is that role-based, I mean, logically speaking, they are essentially the same thing, that you express constraints in terms of attributes or roles. You do not mention users when you talk about access controls. But there's a very important difference in that roles are express all of the access and visibility constraints in the role. Now you can have arbitrary inheritance between roles, but that's actually not that widely used. And it leads, because it's arbitrary inheritance, it leads to very complex situations. And so since you express essentially all of the constraints in the one role, so the role might be marketing's daily data ingest. Now, all of the things that the ingest for that sort of data can do is expressed in that role. The problem with that is that you have an explosion in the number of roles because the entire logical combination of impacts has to be expressed there. The second aspect of this is that it's very, very hard to enforce top-level controls because you can always change to an or. You can always say, oh yeah, or the evil person could access this data. Somebody could change that role in a fairly arbitrary way and cause real havoc. And because of this lack of Boolean combinatorial capabilities, you wind up with that explosion, and you are unable through inheritance to enforce top-level controls. What that means is that in practice, that these roles are administered by a senior administrator who's supposed to have the whole world in their head. That leads to problems. You have to set up a ticket to change that role, and it's slow because they're on vacation today or something like that. And it's inaccurate because the top-level administrators do not understand the low-level constraints, just like the low-level administrators don't understand the top-level constraints. You have to walk the walk to really understand this. And so in addition to the multiplicity, you wind up with a displaced administrative burden, which leads to slow happening and inaccurate execution. That's the primary difference between this attribute-based and role-based. With attribute-based, we would establish an attribute at the top level that would be inherited. No more low-level changing of high-level constraints. Everybody has the attributes needed for the high-level policies. The policies would also be inherited. At the simplest level, just visibility. And role-based access control can express all of this, but they cannot express it in an economical and easily administered way. And let's talk about one of those complex local constraints here. This would be different for you or for me, actually. This is an example that represents how some people might do this. You might have a production data flow, a pipeline, and development. There's no way that your pipeline is completely done the first time you implemented it. Instead, you need a development work pipeline, and you need to be able to read this production data, the green data, The green data is the square green things. With development programs, you need to be able to read the production data. You need to be able to read the production data or the development data as well. So step one down below, the pink circle is reading from raw 2 and the development version of raw 1. Step 1 in the production side is reading from the production data only. And the cleaner cannot read or cannot be written. The clean data cannot be written by the development system. And the development data that's been cleaned cannot be read by production instances. So we have kind of what happens in development stays in development. We allow data to be read or written downward, but we do not allow it to be moved back up. Once data or control or processing leaves the green zone, it is tainted and can never come back. And the way we implement that here is we would have data directories for dev and for production. We would have 2 roles, dev and production. And we would have workload directories, dev and production. And we would inherit constraints. The only things that can write to production are production workloads. Now, we may inherit a lot of stuff from up above, but here we're going to only express what we care about at this low level. And the only things that can read development data are things that have the development attribute or the users in general. Notice the production attribute is not in the reading of development data. We also would add a read permission to the production data if we wanted to restrict it. Without that limitation, everybody can read the production data. So then we have a role at the top, at the Acme user level, and we have 2 roles set on the directories for the workloads. So they will inherit this. Now this enables the DevOps person to promote a program to production by just moving it from dev to production. Bada boom, it now inherits the roles and all of the controls take effect. We also know that because of inheritance, all of the top level corporate constraints that in a day-to-day sort of thing, role, we don't really care. We care about our little micro controls. We don't care about the global controls because we're busy. But we know that they will be handled correctly. The 30-second audit still applies. So we get everything by inheritance. The developers don't touch the roles. They can't change the roles, so they can't screw them up. They have a very simple life. Move it from this directory to that directory to deploy. All the permissions just happen. And we can delegate this much control, this complete local control, without compromising high-level controls. Now, we can do further. We can go to cell-level control in conventional databases. Now, the way that this normally works is an application, usually on behalf of a user, requests access to something. In that request, it provides identity proof and so on, and usually says, I am so-and-so working on behalf of so-and-so. And here's the proof that they have given me the delegation. What comes back is a URL and a key, a short-term signed access key to get to that data. And then the application will go read that data. So every time we want to access data with a different access control, with a different high-level URL that we would put in this request, we have a round trip to the access manager. If we're accessing large data systems, like an entire data lake or an entire Deos key value store or an entire Delta Lake data set or an iceberg data set, this is fine because the frequency of these access requests is very, very low. A single application might make these requests every 10 minutes or so, not every 10 microseconds. On the other hand, if we want to apply these controls differently on every row of a database, we suddenly are trying to decide at microsecond or even nanosecond level timescales. And so what we're going to do is we're going to change the credentials that people would normally get, which says, here's the content you can access, here's the access permission, here's when it starts and expires, who did I issue to, and how did I sign it. We're going to change that to drop the content identifier and the access permission and just put in the attributes that you have. So whoever has this document, as long as they are the one that it is issued to, or it's anonymous, has these attributes. They have the attributes because they have the document. They could pass that on to a database. They could put that in a global config parameter that's session-based, and now the database can look at the attributes and make access control expression decisions at that level. So the queries which access protected data actually access a view where we have, for instance, a query that refers to the parents directory, the parents table, I mean, those are views, not tables. And the way that the view is constructed is by looking at the actual data, which is secret, and augmenting it with additional auxiliary tables that store the access control expressions, specially compiled for fast evaluation. And then all of that is glued together in the view. Now, if we're doing large scale in-memory things like with Parquet, we would do this a little bit differently. We would use a key dictionary instead of an attribute document. And so this view, roughly, looks like this. We create the view called parent as a query on the actual table, which is the secret table, which we're going to call TBL. And then we're going to filter the accesses per row. And we're going to filter at the cell level as well. So we have this filter function and this mask function that have to be written. But that's all that we have to write. And those two functions are very, very simple. All they have to do is check that these access attributes satisfy the particular ACL that's being passed into the mask. If it passes, if it matches, then we can return that cell to the reader. And so the dashboard or the user would do a query against what they think is a table. That's all that they have access to, and their access attributes will be applied transparently. This is a late breaking capability, but it extends this dramatically. We also can do audits. We talked about the 30-second audit earlier and the way that inheritance makes it easy. We can just look at the directories at the level that we're working. If we want to do a high-level audit, we look at the high-level directories and verify that those permissions, which are inherited by everybody below, are correct and express the constraint we want. If we want to audit a low-level constraint, like the production dev separation, we only look at the low-level permissions and everything that's inherited down below there. But the fact that these are so simple means that they can also be used in a formal proof. And by a formal proof, I mean literally a mathematical proof. Here is the critical set. The intersection of the critical set with other people is nil. Therefore, we prove that nobody has access outside of the desired groups. And we prove that inside the desired groups, we do have access. These mathematical proofs probably wouldn't look necessarily so much like mathematics Here, for instance, are the semantics of the access manager expressed in data log. That's a first order logic system that allows very simple proofs. We might write the actual proofs in a proof system like Lean, which allows for automated checking of proofs. But the fact is that it's the simplicity, the core simplicity of the system, which makes it feasible to talk about formal verification. Formal verification is normally restricted to very obscure situations. For instance, Intel and AMD can do formal verification on parts of the CPU chips that they produce because they are going to sell millions and possibly billions of those chips. They can amortize the cost of formal verification. In normal world, formal verification is a theoretical entity that we can't really afford to apply. But if we could simplify the universe to the degree that this access manager does, we can make proofs. We can make actual proofs that the path data acme has the view permission. We prove that by inspection. And that attribute is the only one that has it. The attribute is found only under the acme directory. And since the acme directories only have the view, nobody else can see that thing. That attribute has limit on who can use it. To those with the admin is held by the trusted user. So we can make a proof here, not only about the current state of the system, but about what future states it might have. As long as those admins are trusted and they are the only ones with the admin attribute, their trust implies trust in the entire system. This is really, really important. We can prove it over all future states. And because we can maintain a history of all metadata, we can also make proofs about what could have been done. The auditor comes in and says, yeah, I was here 6 months ago. It looked good then, it looks good now. But was it good at every point in time between my visits? We should be able to prove that that was true for every moment in time. Our new policy, our adjusted policy was satisfied in the past by accident, but in the future by intent. These proofs can also be injected as metadata unit tests so that we can verify that the changes that we make to the metadata will not compromise the policies that we want, the complex policies that we want to have in place. So for instance, we might have a policy that the top level administrators can administer any level down to the department level. That means no department level, no BU level administrator should be able to cut off visibility and administratability to the corporate administrators to that level. Well, we can check it so that then if those low-level administrators start to make a complex violation of that policy, they would be stopped immediately and notified exactly what they were doing that's wrong.
Ted, we have a question from Manuel.
Great. And we're coming up on the discussion time, so that's good.
So, well, it's a simple one, but does it work only for databases? But I'm pretty sure the answer is for any relevant data, not necessarily in the format of a database. Am I correct?
Yes. And so the way that works, for instance, if we want to secure a database and S3 assets and assets in Azure and assets in Deos, each of these different systems has a different way of manufacturing a short-term credential. So on S3, we use STS, the secure token signing system, in the account where the data lives. And that will give us a secure time-limited bearer credential, which is actually role-based, not attribute-based, but it's limited to that session role. That gives us the limited right to read or modify the S3 data that we're after. Now, if it's Azure Page Blobs, Azure or Google or whoever has similar short-term credential systems that operate the same way. And so we would have in this directory that the credentials are manufactured for S3. In this directory, they're manufactured for Azure. In this directory for Google. In this directory for Deos. And so for any sort of data system we have, we plug in the little factory that manufactures the credentials for that kind of data. It's not just databases. In fact, that is one of the major goals. Internally, we have data in all kinds of systems at HPE for obvious reasons. I mean, it's just like everybody else has data in multiple places. And right now, the access control, when you have data in multiple places, is just as fragmented as the location. You control things one way here, a different way there. And that can probably be glued to some kinds of your identity system, but not all of them. And that is a nightmare. As bad as role-based access control is, which is better than what went before it, but as bad as it is, as complex as it is, as accident prone as it is, it gets much worse when you have multiple RBACs that you have to deal with, as opposed to one uniform system that works with all of the different kinds of data. And so I'd like to open it up for questions. Is there anybody out there who has customers that complain about complexity of data or about the risk of data loss? Come on, let's see some hands. I would expect everybody has hands. They know somebody, or they have a family member who has this problem, but it's okay to speak about it. Well, if we don't have these questions, then I'm going to say that we should be done.
One question, Ted.
Good.
On the slide, I mean, but I can see the slides are tagged confidential. So will they?
Yes, this is a formerly internal presentation. It
Okay.
only contains public information. I will release a cleanly marked public version of
Okay.
the
So
slides.
there was a question earlier on whether the slides will be made available. So
Yeah.
it answers the question.
And
Okay.
this is formerly non-public research. It's now okay to be disseminated at this level of detail.
Okay, fine. So if anybody's got a question, this is the time. Use the Q&A or use the chat. And
If anybody has used Emerald Data Fabric, formerly MapR file system, MapR Data Fabric, they may have seen some of these concepts already. In Data Fabric, there's a concept of a global namespace over all assets in the Data Fabric. And there's a concept of volumes, which are directories with management superpowers that cannot be nested, but they allow you to control access control expressions that are full Boolean at the level of volumes. And that has proved very, very valuable in a number of customers. But the question always comes up from these customers. This is great. This is exciting. Can I have it for all of my other data? That was some of the inspiration for this work.
Okay. In the meantime, I launched the poll. So for the attendees, if you mind, please, do answer the poll. This is the simple questions about the sessions, with a good use of your time and the level of and the value to the customers and so on. So, and for in the meantime, while you're responding, I'll be thanking again Ted for this session. Now I better understand I was the issue.
And I'm sad to see that hosts and panelists can't vote. So it's up to you guys out there to vote for us.
Exactly, yeah. And so you can reach out to Ted and to us the dev community. Would you mind restating your the way you said you were not on Twitter anymore? So
Yeah.
if people want to reach out to you
There are multiple ways to reach out. For one thing, you can just send me email.
first.
That's less public, more private, and so on. My email is my name, ted.dunning@HPE.
Mm-hmm.
On Blue Sky, I'm tdunning.bsky.social. And so you can reach me there. I may change that to tdunning.com, but it'll always be tdunning, initial and last name.
Okay, fine. So if there are no other questions, and I think that I will leave the poll just a few seconds more. And oh, okay. So there is one more question, Ted. Will the Harmony Access Manager be public at all? So you somehow answered it already. You said that it was now because
Yeah,
this is
yeah, this is
that repo that you were showing was an HP one. So will it become something more open over time?
that's an interesting question. And it really depends on what our customers really want. We are introducing these concepts. Some of them have already made it into the Harmony system, which is for internal applications to access internal HPE data. So the Harmony Access Manager will never become public. It's for us to control and simplify our own internal operations. But the Access Manager at large is much more plausible to become publicly available. But it crucially depends on demand from customers. Will this help us with our customers? Will it help our customers succeed? That's the core question. So there's a couple of German automakers, for instance, who are very keen on this. There are some US government agencies who have had, security concerns in the past. They want to simplify that enforcement. They're very keen on this. If this looks like it means that we really could make them more successful if we could collaborate with them in an open way or a semi-open way to move forward on these concepts, then yeah, it probably will be public or semi-public. But that really depends on people coming back to me and saying, we need this, raise your hand. That's how it'll become public. Great question.
Okay. So we still have 2 minutes left. So if there's any more questions, this is the time now. Otherwise, I suppose
Just pretend that you've already left and you can come up with a question that you would come up with just after you've left, but you can do it now.
exactly. So nobody shows up or
Okay.
or anything. Then I
Those have
will
been
thank you
really
again,
good,
Ted. And
really good questions so far. And thank you, Fred, for hosting me.
my pleasure, as always. Don't worry. And so the replay will be made available over the course of next week, I believe, because Didier is in Barcelona enjoying tapas and Discover at the moment. So we'll give him a rest when he'll be back. And so hopefully let's say by the end of next week, the replay, and he'll be contacting you for the curated version of the slides as well to make them available on our web portal. Okay. So with that being said, we'll say goodbye. Thanks again for attending, and check the agenda for the forthcoming session, and we'll be talking to you next time in December on the 11th and on the 18th.
And
Thanks a
thank
lot.
you,
Goodbye,
Edward, Steve, John, Vera, and
everyone.
folks who are saying such nice things.
Yeah.
Thank you
Everybody,
very much.
you did a brilliant presentation, and they all thank you. So that's really cool. Thanks a lot. We'll be ending this call right now. Have a nice end of your day. Bye-bye.
Bye.